In this video, we're going to learn how to create a histogram visualization as part of an HTDAP program. We will start with the beginning of a program that we designed in previous videos. I will keep the planning steps and make systematic changes to these steps where necessary so that our program can create a histogram. A histogram is a visual representation of the distribution of numerical data. Each data point is put into one bin, and the height of each bar in the graph corresponds to the number of data points that are in that bin. For this example, we'll examine the natural increase of BC's population, which means births minus deaths, as a percentage. I've examined our data enough to know that every year, the percentage of natural increase is less than 1%. So we'll bin our data into years that grew 0 to 0.1%, 0.1 to 0.2%, etc. Step 1A does not change as our file still contains the same information. Step 1B needs to be updated as we need to add our histogram as a possible program output and choose it as our goal. Our goal will be to create a histogram that bins the natural increase of BC's population, which means births minus deaths, as a percentage. That's no longer phrased as a question, but it does explain what our goal with our program is. Let's work through the rest of the program design and make necessary edits as we go. In step 1C, I need to update the example. Previously, when our programs produced a non-visual answer, we could write our example in the form of an expect, which was sufficient to show what type and form of answer we expected our program to output. When our program will create a visualization, like our histogram, we want to write an expect and draw an example of what our program will produce. I like to hand draw the examples, although you could use a drawing program on your computer if you prefer. Once you've hand drawn the example, you can take a picture of it and then insert the image into your markdown cell using the Edit menu Insert Image option. The purpose of the example is to think about what we want the graph to look like. We are not trying to draw the exact output. In other words, you should not worry about finding all the exact data points, binning them, and drawing the exact bars that you expect. Instead, focus on what each axis will represent and what a rough shape of an output graph might be. I also need to update my expect. When we design functions that create a graph or chart, they always return none. Since main will call the function that creates the graph or chart, it will also return none. The data definitions that we built in the previous example do not include the total natural population increase, so we need to update them. As a quick reminder of what we're starting with, we have a compound to store a year's population change and a list of these population changes. We need to update the population change compound to include the total natural population, and we'll work systematically through the steps of the How to Design Data Definitions recipe to make this change. First, we'll change the data type definition to include the total natural population and its type. I'll call it nat increase for natural increase, and its type is integers because it's counting individuals. We do not need to include a range because it's possible for this number to be positive, which would mean more births than deaths, or negative, more deaths than births. Next, we need to update the interpretation to include the total natural population increase. To update the examples, I've looked at the information in the CSV file and have created updated examples to copy and paste in. Finally, we need to update the template. Nothing needs to change in our list type. Since we updated our data definitions, our read function for step 2b also needs a slight update. We now need to read in the total natural population from column 7 and parse it as an integer before we create our new population change data point. I will spread these out so they each have their own line to make sure that our line of code does not go beyond the end of the cell.